Welcome back, students. Today we're going to be talking about arc length. Now, arc length is just the distance around a specific segment of a circle. When you go all the way around a circle, like I just did, that's what we call the circumference. Now, I'm going to try to relate the arc length to the circumference and also back to what we've been talking about with radians. Okay? Now, radians are the distance around the unit circle. So, if, for example, we were to look at this circle right here, the length to go from the beginning to there of this line around the circle is pi thirds units long. And we can do multiple other lengths, so this would be 7 pi 6. Now, these length of arc measures, these are only good for the unit circle. And in a previous video where I talk about how to convert between degrees and radians, those radians are specifically on the unit circle and do not apply to other circles. Anyways, let's come back here and let's do a simple measurement of the circumference. It's got a nice easy equation. The circumference is 2 times pi times the radius. Here, the radius is 1. So the entire circumference is just 2 times pi times a 1. So the circumference is 2 pi, which is exactly what we'd also get from the unit circle if we went all the way around. This circle is 2 times bigger. It's twice the size of the other circle. Now, as I calculate its circumference all around, we have 2 pi multiplied by the radius, 2, which will end up with 4 pi. The final circle is 3 times bigger than our unit circle, and we would calculate its circumference by doing 2 pi times 3, which is then going to give us 6 pi. Now, one thing I want you to notice is the relationship from the unit circle measurement to the other measurements. So the unit circle measurement for the full circumference is 2 pi. When we go up to a circle that is twice as big as it, that goes to 4 pi, or in other words, just twice as much. If we start from the 2 pi and then go to a circle that's 3 times bigger than it, well, it's 3 times bigger. 2 pi times 3 would be 6 pi. So by changing one dimension, the radius, we then change the other dimension, the length around the circle, by the exact same amount, by multiplying by that same amount. If the radius is twice as big, the circumference is twice as big. If the radius is 3 times as big, the circumference will be 3 times as big. All right, so now let's look at an actual arc length. So you'll notice we got the same circles here, but now we only care about a certain portion of it. Now this was chopped up nicely so that we can see we only want 1/4 of what the original circle did. So if I calculate that out, above that circle had 2 pi. So 1/4 of 2 pi is pi halves. Over here, 1/4 of the 4 pi that one had would just give me pi. And then 1/4 of the 6th pi that the other one have would then be a 3 pi halves. And I want you to notice a similar relationship has just happened again. Now, yes, these ones going below, they were 1/4 of the arc length. So they were 1/4 smaller. But what I want to focus in on is starting here from the unit circle, going from pi halves to a pi. Remember, this circle was 2 times bigger. Pi halves times 2 would give me pi. The other circle was 3 times as large as our unit circle. 3 times pi halves is 3 pi halves. So in order to figure out these arc lengths of circles that are much larger than the unit circle, we just use the numbers from the unit circle. We can use them as our starting point, and then we could easily just multiply depending on how many times bigger the other circle is. So let's look at some problems that are related to this. So I've got this circle. Notice this circle is 8 times bigger than the unit circle. Now, I am told that we've got 165 degrees there. One thing I have taught in a previous video, converting degrees and radians, is how to take our degrees and change those into radians by multiplying by pi over 180. And if we do that, then we're going to get 11 pi 12ths. Now, this would be the radian measure if this was the unit circle, but this isn't the unit circle. This is a circle that's 8 times bigger. So all I really need to do to scale this radian measure up is multiply it by 8. And after we do that and simplify, we get 22 pi thirds. And that is the length of the arc of going around the circle that has a radius of 8, 165 degrees. Okay, so now let's do that again. Now, once again, anytime you need to convert your degrees into the radians on the unit circle, you can quickly multiply it by pi over 180. Some things should be easily recognizable. 315 degrees, I should be able to easily find that on a normal unit circle. So 315 degrees right down there. Notice it is connected to 7 pi fourths. So as I come back over here, I know that my 315 degrees is the same as 7 pi fourths radians on the unit circle. This circle is 14 times bigger than the unit circle. So we're just going to multiply that radian measure by 14 because this circle is 14 times larger. As we do that, we then get our answer. We simplify it and we get 49 pi halves. All right, final one. We got 270. Now, once again, you could go through the trouble of doing pi, multiplying by pi over 180. You can also look on the unit circle. There's 270. The radian measure would be 3 pi halves. So we got 3 pi halves. This circle is 4 times larger. So I'll multiply it by 4, and we get 6 pi. So that is how you can find the arc length using the degrees and a radius measure. All right, good luck on your work.